So this video is going to go over modifying, extracting, and repackaging our modified firmware, and then how we can upload it to the TP-Link device we have. So in order to modify and repackage our firmware, we're going to use a tool called Firmware ModKit. I'll leave the GitHub repo in the description so you guys can easily get to it. So if we come to the firmware modkit directory, we run ls, we have a few commands here. We have build firmware and extract firmware. And these are the commands that we're going to be using today. So if we just extract the firmware with the extract firmware.sh command, and we need to make sure our firmware is in the same directory, it just makes it easier for us. So if we extract this firmware, you'll see here it started extracting it. And one of the main things you want to look at here is we have a squashfs file system, but it's also a little endian. So this will be important when we make our backdoor. So we want to make sure we remember that it's little endian and not accidentally make big endian file for our backdoor. So now if we just cd into the FMK and list everything out, we have the root file system. So if we go to the root file system, we see we have here a little Linux file system, just a basic little file system. Now we need to find a bash file in this file system that will call our file and run our payload, our backdoor, when this device boots up so that we can have a persistent remote shell into the machine. So we can just use the built-in find command, and we can have it look for any bash file that is in this. Now it needs the right command. And here we have the sbin config file. So the sbin config file is going to be the file we're going to target to upload our backdoor to. So now we need to create our backdoor. And I'm just going to create it in the TP-Link directory that I've been having all my files for the TP-Link firmware. So in order to do this, we'll use a tool called MSM Venom, and it will help us create our payload. So we want our payload to be a Linux payload, and it's going to be MIPS LE, and that's the LE for little endian to make sure that the firmware understands our file. And then we're going to make a bind TCP shell. Then we're going to set the listening port to whatever port we really want. And then it'll be in ELF format. And then we'll have it output to our file, and we'll just call it backdoor. Now, after a little bit, this will give us our payload. Then we just need to copy it into our firmware. And then from there, we're going to have the sbin call it on execution. So in order to move our file from our current directory to the firmware, we're just going to use the copy command. So we're going to copy our file, the backdoor, and we're going to put it in the bin directory of our firmware. So we need to go to trunk, fmk, root fs, and then bin. So now if we come back over to our firmware and we ls bin, we have our backdoor right here. Now you may need to, let me cd into the bin. You may need to make sure that your file is an executable. So if you needed to change it, you would do sudo change mod plus X, and then your file name. That is if it's not an executable yet. So now with that out of the way, we need to add our file to, like, the call to our file to execute it to the sbin config file. So now in order for our backdoor to work, we need to edit the sbin config file. So we'll cd into sbin, and we can use nano to edit the config file. So now all the way at the bottom, we're just going to add the call to our backdoor, and now we can save our file. Now our firmware has been modified the way we want it to. We can back out to the trunk directory, as we are here, and now we can use build firmware.sh to build our firmware. So as you can see, it's building our firmware for us. So now it says our firmware is saved in FMK as new firmware. So yeah, we have new firmware.bin. So now the issue is going to be uploading this file to our target device. Now, this particular TP-Link router does have an option to upload firmware to it, and you would select a firmware file, but that doesn't work anymore. So we need to do something else in order to upload our firmware to it. And what I found it works is recovery mode on the TP-Link router. So what happens is if you were to brick your TP-Link router, you can hook it up with Ethernet to a TFTP server, or just a TFTP host. And TFTP is Trivial File Transfer Protocol. And if that host is set up properly, it will take the TP recovery.bin file and install it on our router. So what we would do is, what you want to do is download TFTP. I think it's TFTPD. Yeah. So you would download this, and I'm going to run it on my Windows machine. And then you set it up so that the TP-Link router can find it when it's in recovery mode. So we're going to go over that now. So over here on my Windows machine, we have a few windows open, and I'm just going to explain them all really quick. So this is our TFTP file, and here is our backdoor. We have to rename it tprecovery.bin because that's what our router is going to look for when it's in recovery mode. Down here is the control center for network connections, and because we're going to hook our device up to our computer's Ethernet, we actually need to configure our computer's Ethernet. So what we want to do is go to IPv4 and go to properties, and we want to set it to this IP address because that's the IP address that the device is going to look for. Lastly, in the top left up here, we have the TFTPD program. So this is what's going to hold our file and how it's going to transfer it over to our device. Now, you may also need to turn off your Windows firewall in order for this to work, and obviously just remember that you turn that back on. So now, with the Ethernet plugged into our device and plugged into our computer, we can plug it into power, and then we press and hold the reset button while it boots up. And this will cause it to go into recovery mode. And then if you see in a little bit, it's going to transfer our recovery file to our device. Now, after it's done that, our little router here is going to reset itself and it's going to install the new firmware that it just downloaded. And then after that, we'll be able to remote into it and just have control of the device. We'll have a persistent remote root shell on the device. So now back over on our Linux machine, we're going to run MSF console. So this is Metasploit Frameworks console. This is going to be how we connect to our backdoor and how we interface with it. It'll take a little bit to boot up, but once it's ready, we'll just be able to run our commands and execute our payload. So now that MSF console is finally loaded, we're going to tell it what to do. So we want to use the exploit multi-handler, and then we're going to tell it our payload is Linux MIPS LE, and it's a shell bind TCP. This is the payload that we put on our own device. So now we're just going to set the listening port again, which is the same that we put on our device. And then we set the R host, which is remote host, so it's the IP address of our target device, which in this case is 192.168.0.1. So now that we have all the options set, all we need to do is exploit, and Metasploit is going to handle the rest for us. It's going to connect to our bind shell and give us a console that we can interact with. It does take a little bit for it to work, but as you can see here, it started a bind TCP handler on our target device, and now we have a command shell session. And as you can see here, we're in the device. I don't believe this command works. Yeah, it won't show it to us, but we can see the processes running. We can see our backdoor is running, and now we're in our router remotely as a root or admin user. And then from here, we could do whatever we want to. So that is all for the video today. Thank you for watching. I think I'm trying to decide what my next video might be, so you guys could let me know in the comments, but I might do a video about Bluetooth hacking, or if we want to go more in depth, I might look into some of the things we can do once we have this remote root shell on our router. But anyway, thanks for watching and stay ethical.